Ever pondered why Venus, our neighboring planet, spins in the opposite direction to most other planets? Yes, that's right. Among the vast celestial bodies that make up our solar system, Venus is a bit of an enigma. It's like the rebel child of the Planetary family, refusing to conform to the norm. You see, most planets, including our very own Earth, spin on their axes from west to east. But Venus, it dares to be different. It spins from east to west, a phenomenon we call retrograde rotation. Now you might be wondering, what's the big deal? Well, this unique characteristic of Venus has been puzzling scientists for decades. It's like a riddle written in the stars, an unsolved mystery of our universe. So what makes Venus dance to its own tune? What could be the reason behind Venus's backward spin? Ready to dive in? Before we delve into Venus's peculiar rotation, do you know how planets normally rotate? Let us take a journey through the cosmos to understand this fascinating concept. In our solar system, rotation refers to the spinning of a planet on its axis. Imagine a top spinning on a table. It's a similar concept. This rotation gives us our day and night. When a part of the planet faces the sun, it experiences daytime, and when it faces away, it's nighttime. Simple, right? Now, most planets in our solar system, including our home, Earth, follow a similar pattern. They rotate from west to east, in a motion called prograde rotation. This is why the sun appears to rise in the east and set in the west. This rotation is largely influenced by the initial conditions in the cloud of gas and dust from which the planet formed. As this cloud collapsed under gravity, it began to spin to conserve angular momentum, much like a figure skater spinning faster as she pulls in her arms. However, not all planets rotate at the same speed. For instance, a day on Jupiter lasts only about 9 hours and 55 minutes, making it the speedster of our solar system. On the other hand, Venus, our topic of interest, has a rotation period of about 243 Earth days, the longest of any planet in our solar system. But wait, there's another twist to this cosmic tale. While most planets spin from west to east, Venus, along with Uranus, spins from east to west. This is known as retrograde rotation. Fascinating, isn't it? The question then arises, what makes Venus, named after the Roman goddess of beauty and love, dance to a different tune? Why does it not follow the west to east rotation like most of its planetary brethren? So if most planets spin from west to east, why does Venus spin from east to west? Well, let's delve deeper into the mysterious world of Venus to find out. Have you ever heard about the giant impact hypothesis? This theory, one of the major explanations for Venus's retrograde rotation, posits that Venus's peculiar spin might have been caused by a colossal cosmic collision. Imagine, if you will, a planet spinning happily in its typical prograde motion, just like most of the other planets in our solar system. Then, out of the blue, a rogue celestial body, perhaps an asteroid or another planet, smashes into it. The force of the impact is so tremendous that it literally sends Venus spinning in the opposite direction. Quite a dramatic twist, isn't it? Now let's delve deeper into this hypothesis. The idea is that the offender, the celestial body that crashed into Venus, must have been quite sizable. We're talking about a body with a mass similar to that of Earth. The collision would have had to be at a specific angle and speed to not only stop Venus's original prograde rotation, but also to kickstart its retrograde spin. This theory, while fascinating, raises numerous questions. For instance, where is the evidence of this massive impact? Shouldn't there be some sort of scar or other trace left on Venus's surface? Well, the answer to this isn't straightforward. Venus's surface is relatively young in geological terms, around 500 million years old, and it's constantly being reshaped by volcanic activity. This means any evidence of such a cataclysmic event might have been erased by Venus's own geological processes. However, the giant impact hypothesis isn't universally accepted. Critics point out that the specifics required for such an impact, the size, angle, and speed of the colliding body, are incredibly precise. The chances of such an event occurring are, statistically speaking, quite slim. So, we're left with a tantalizing question. But is a massive collision the only explanation for Venus's backward spin? Well, stay tuned as we explore other theories in our quest to unravel the mystery of Venus's unique rotation. What if I told you Venus wasn't always spinning backwards? Yes, you heard that right. There are theories suggesting that Venus might have started its life like any other planet, spinning in the same direction it orbits the Sun, a type of rotation we call prograde. One such theory proposes that Venus initially had a normal prograde rotation, but over billions of years the immense gravitational pull of the Sun, combined with the planet's dense atmosphere, acted like a gigantic brake. This slowed Venus down and eventually caused it to spin in the opposite direction, a rotation we call retrograde. Another theory, known as the giant impact hypothesis, suggests a colossal collision. Picture a space rock about the size of Earth smashing into Venus with such force that it literally reversed the planet's spin. A dramatic event indeed. Yet another theory involves Venus's thick atmosphere and its interaction with solar tides. The idea here is that the atmospheric tides driven by the sun's heat could gradually have caused Venus to spin backwards. Each of these theories has its own merits and demerits, and all are still subjects of ongoing research. The truth is, we simply don't have a definitive answer, not yet at least. To wrap things up, let's quickly summarize. We've delved into the peculiar phenomenon of Venus spinning backwards, a unique trait among our solar system's planets. We've explored how planets generally rotate and pondered the enigma that is Venus's retrograde rotation. We've unraveled some theories from the effect of the sun's gravitational pull to a cataclysmic collision, and even the influence of solar tides on Venus's dense atmosphere. While we may not have a definitive answer, the mystery of why Venus spins backwards continues to intrigue scientists and space enthusiasts alike. What's your theory?
Don't forget to like, subscribe, and share this video. That's all for Nifty Narrations.